we're designing our game analysis decision support tool using big data analysis. Just to give you an idea of what our program does, it starts as big data, which is gathered from all of the games, and it applies them to the coaching methods, which is then evaluated in our match performance, and hopefully it allows our teams to win more. So first, just going to go over context. So to go over just the NCAA, it's one of the biggest national nonprofit collegiate sports organizations in the U.S. There's 1,000 colleges and 400,000 participants. They're broken down into 3 levels: Division 1, 2, and 3. Division 1 being the best, Division 3 being the worst. And these are the major powerhouses in Division 1. The correlations between Division 1's competitive success is they're mainly based on their budget. As you can see on the graph on the right, from 2005 to 2020, the budgets of these top 10 public institutions increased from $69 million to $254 million. These are for these athletic departments. So just to go over our value hierarchy with all of this stress on competitive success throughout Division I in sports, this is how George Mason Intercollegiate Athletics evaluates their coaches, and this breakdown is in their coaches' evaluation. It's based in 2 groups, leadership and management, and those are broken down further. And we wanted to focus on competitive success because this is what the coach has the most control over. So competitive success is evaluated into 22.5% of the entire evaluation. So this is also a very high weighted evaluation criteria. So next is a functional block diagram of the process of a volleyball program. It starts with a match, and then the blue box is where our simulation would fit in. But if there wasn't there, it would go to a match, and then it would go to post-game analysis, where the coaches perform training development, where what they need to focus on, so refining the skills of players or recruiting a new player for that position. Then it goes into the physical training, and then back into a match. Next, just some context of the background. This is the women's volleyball program, and we compare them to Northeastern. You can see in the graphs of their winning average on the left and their variability on the right. So they're decreasing trend while Northeastern's increasing trend for their variability, and their win percentage average is much less. Now for the men's, we compare them to Penn State because Penn State and Northeastern are the best teams in the men's and women's conference, and if we can beat them, we can beat any other team in our conference, essentially. So again, comparing Penn State to our George Mason men's, and on the right is the variability graph. So just stakeholders, I'm not going to go into this in detail, but the NCAA athletic department and volleyball programs are our main stakeholders. They're broken down into more sub-stakeholders. Our problem and need statement. Problem and need statement, if for our women's, was that our women's are only winning 3 out of 13 matches between 2006 and 2012, and that's only a 23.07 win percentage. That's the problem against Northeastern. So obviously their need statement is to increase their win percentage, and that's hopefully what our tool will allow them to do. Again, with the men's only won 2 out of 26 matches against Penn State between 2006 and 2012, and that was only 7% chance of winning against Penn State, so they need to increase their chance of winning against Penn State. So design alternatives. Design alternatives were based on the transitions that occur in a game, so serves, blocks, attacks, and decreasing errors. I'm not going to go over this hypothesis testing, but this is just basically we compared the transitions that occurred to the other team's transitions to see which transitions occurred more and what transitions that were significantly different from the other team. So this is our CAAT, or Computer Aided Analysis tool for the volleyball programs. So as you can read through this, it's what the tool does. It's a robust volleyball decision support tool. It uses mathematical based using a Markov chain. It's a computer-based program written in Java. It simulates matches, it allows for analysis, and it allows the coaches to evaluate the occurrences. So this is our absorbing Markov chain game model. It has the transient states and the absorbing states in the beige and the transient states in the white. It starts with a serve from team A or team B, and it goes through all the transitions that could occur. This is just a further breakdown. Now this is our absorbing Markov chain model, our Markov matrix, and this is how the calculations that we performed. So the Q matrix is the transient state matrix, and the R matrix is the absorbing state matrix, and then the I is then blown up into a 10 by 10, and we use the calculations 1 through 3 at the bottom of the screen to be able to calculate the eventually going to a absorbing state. So this is the matrix that we come up with. So it comes up with a 2 by 10 matrix, and this is the transient states eventually going to the absorbing states. And our formula was to sum up all of these values to be able to get the point scoring probability, and this was matched or used to validate our simulation. So this is going into our simulation, so just some simulation assumptions. Our first assumption was that the opposing team's performance remained consistent based on the background I gave you earlier, and design alternatives also were changed, and all other transitions in the states remained the same as their current status, and George Mason probabilities were the only ones that we could control, not the opponents. So then again, this is just something I'm going to go over more into detail. Our simulation occurs, it starts with videos and this post-game analysis tool like I said before. This is where all of our raw data is collected, and then it parses the data using our Python script. Once we have this, our transitional probabilities can be inputted into our simulation, our outputs for our winning percentage and point scoring probability, and also the sequence of events that occur within these matches. From that, we can parse that and get our transitional occurrences, and then we can make a sensitivity analysis. So this is just further blown up just to give you an idea. Our user input looks like and then parses into this matrix, and as you can see, you can change our design alternatives from the transient state on the left, so a serve going to a point, you can see a serve and then it says 0 next to it. Just ignore the 0, that's for programming purposes, and then you can follow it to a 9 on the column, and that's point for team A, and so the probability is 0.03. And I'm just going to play this video. Oh, sorry. If it loads, hopefully.
Hi everyone, my name is John Tigno, and I'm going to be going over how to use Precision Support Tool for the George Mason Volleyball programs, or the CAAT version 1.0. Now, at first glance, we can gather some of the features this simulation incorporates. It has 2 menu items, it has outputs in the middle of the screen, inputs of number of matches, and 2 functionalities of simulate and change probabilities. And from the simulate tooltip, we can gather that it simulates the number of matches specified, but we first must select the team file. So I'm going to go over here from the menu item and select the team file. And in the bottom left, it displays what team is competing, the George Mason men's, and who they're competing against, Penn State men's. So once we've selected the team file, the simulate button becomes active and we are able to simulate matches. I'm going to go ahead and run a simulation of 1,000 matches between the George Mason men's and Penn State men's. This first initial run will give us our baseline values for win percentage and score efficiency for both George Mason and their opponents. Once we have these, we're able to alter some of our transitional probabilities as specified earlier. So we have our baseline win percentage of about 4.1%. It's not that great. So we want to be able to alter some of these transitional probabilities to be able to see what it will affect and increase our win percentage against Penn State University. So from this drop-down menu, we were able to change and alter our transitional probabilities of service aces, blocks to points, errors, kills, and so forth. I'm going to go ahead and alter service aces. So right now, the current probability is at about 0.0359 or 3.59%. So I'm going to go ahead and alter this to about 0.25% and click the change probability button. Once I've clicked this, it alters all the probabilities leaving a serve state. So now I'm going to simulate another 1,000 matches. And once I've simulated another 1,000 matches, we can compare it to our baseline. So as you can see, it increased our win percentage by 60%, which is a very good increase, and also our score efficiency to 0.51. This increase is very great, and we're then able to alter some of our other probabilities.
So that was just a video of our simulation, how it works, and then this is a sensitivity analysis we performed. Now this equation on the left was also built into our simulation, so once we changed the design alternative, we changed the other states based on that formula down there. This is increasing service aces, so we incremented the service aces to see how it affected the point scoring probabilities. So that just gives you an idea. This is a further full sensitivity analysis on all of our design alternatives. This is our design of experiment. As you can see, our design alternative, the transitional probability of the original when they were winning 50% and when they were winning 90%. This is our results and recommendations. You can see some of the graphs in here of how the design alternatives changed when we increased some of the design alternatives. Also, the utility function, this was based on our two main categories, trainability and modifiability, and trainability has two subcategories, efficiency and effectiveness, and the coaches were essentially given this and asked to input their how they felt about their performance on these and how efficient and effective this would be. So the men's utility, as you can see, was decreasing errors, had the most utility and a medium to high risk. The women's utility was the best at the decreasing errors as well. Just to go over our recommendations, so we have our simulation results and our utility results. And our simulation results are slightly different from our utility results. You can just see this in the graph. Some of the future work would be to rank passes and sets and other events to determine whether essentially the bottleneck or transitions to attacking. Also assess first phase side out efficiency, and also maybe do a real-time assessment of the opponent's weaknesses to determine opportunities and take risks in the game. So this is just a testimonial from Coach Fred Chow, one of our sponsors, and he said and highlighted, their model is a good first attempt at informing on meaningful components of success and failure in the sport. All right, that sums everything up. Thank you very much.